All right, welcome Physics 30 students. I'm pretty excited about trying to teach about vector addition, just because I'm going to use a couple things like the ruler and the protractor that I've never tried to use before until today, so we'll see how that goes. It's the reason why we're doing vector addition is, and you could say vector subtraction as well, is because we're dealing with things like forces and, well, even velocity, displacement, acceleration, that you can actually add them up, and often things like forces add up, and you can find the total, like for force, the total force on an object by adding up all the different forces applied to it. So, for instance, if you throw a football, as soon as you release the ball, you could add up, or as you're releasing it, I guess you can add up the force vector, all the forces on it, to see basically where it's going to fly. So the force that you're applying to the ball, the force of gravity, and you add those two up, you can see what direction it's going to go. Also, as it's flying, it's just the force of gravity on it. Anyway, don't want to get all distracted on all that stuff. That's not the question we're doing right now. We're doing a different kind of, we're doing a vector addition one, and it's just displacement. So, displacement vectors. We draw a free body diagram. Typically, we refer to that when we're talking again about forces, but we can do it on a free body diagram here, or we can just draw vectors. The way you add them is, we call them tip to tail. So if this a vector, we usually represent with an arrow. So we might have a vector like this. Vector like this, and then if we had another vector, say like this, if we add them together, we would put this one up here. We would go this and say the resultant vector, which I'll use the dotted line, is this one. So if this is A and this is B, then this would be the total of the two, or resultant vector or something like that. Okay, so let's take a look at this question here. I'll just erase all this, and I'll do some of these questions, and hopefully you'll begin to understand what we're trying to do here. And I can see that my screen moved a little bit. I don't know if I can move that back. Oh. Man, the amateur hour is going on today. I guess I'll just move my picture, my video. Okay. Remember, the resultant vector must have both magnitude and direction, include a scale. So this would be really nice if I had graph paper. But since I don't, I'm going to use a ruler to measure things out. Now the first thing you want to do is just mention that there's a key here, so I'm going to do this a little bit off on the side of the paper. And I'm just going to draw the key for the directions so that everyone knows where things are. And if this is north, this must be south. And then this is west and the east. The way I remember that is that once you have north and south labeled, this spells we. West is we. Instead of EW, it's WE. You can remember it a different way if you want to. That's totally fine. So the first question says A plus B. Well, what is A? A is 35 kilometers at 25 degrees north of east. So if it's 25 degrees north of east, that means if you go along the east and you go 25 degrees towards the north, that would be the direction, and we'll figure that out. And then B is 15 kilometers, 10 degrees east of north. So if you're going in the north direction and you go 10 degrees east of it, that would be the vector there. So I'm going to try to do one here. I don't think I'll do all the questions, but I'll just do the first one here, and hopefully that'll give you enough information. I'll mention what subtraction looks like too. But okay, so the first thing is we need to draw this hopefully to scale. So if we're doing the graphic method, we need to have not that yet, we need a ruler. So this gets a little bit complicated. I know we have one North. So I'm going to bring the A, I'm going to bring a little bit lower. So I'm going to, I think I can just click on this thing and move it. No. Click on it with the mouse. Yes. Okay, here we go. So I'm figuring all this out right now. And I want to go 35 degrees. Wow, this is gonna be tricky. So I'm gonna put a dot here. That's where I'm gonna start. Of course, the dot went lower than I thought it would. It's interesting. Oh, it's on the ruler. Nice. Okay, so it's on the ruler there, and then I'm gonna angle this. So if I'm not on the ruler, can I write? Yes. Okay. So this is my starting point right here. And I'm going to bring the ruler up to it. And it says 35 kilometers. So I'm just going to say that each tick mark is worth 1. So this would be 1, 2, 3, 0.5 would be in here. 1, 2, 3, 4, 5. Okay, yeah. So I'll have to go in the middle of that. Actually, maybe I should go 1, 2, 3. Yeah, that'd make more sense. And this is 0.5. And at 25 degrees north of east, well, I don't know if I can. Yes, I can. Nice. All right, 25. So if this is straight east, okay, if I drew a line here, that'd be straight east. I want to go 25 degrees north, boom, of east, and I'm going to put this right there. This could be my new favorite thing to do here. And I want to just draw a line that goes 1, 2, 3.5. Okay, I'll move this ruler out of the way, so it's 1, 2, 3.5. I'm just going to draw an arrowhead on this. Okay. So this is indeed A. This is vector A. It is 35 kilometers. And I'm just ignoring the decimal 0 for now. 35 kilometers. And I drew it as, if these are centimeters, which they're not, but anyway, you can just pretend it's 3.5 centimeters. If you do 3.5 centimeters, I think that'll be a good scale. Okay, now I want to add to it B. Well, B is, I'll just do B over here and I'll just show you how to add them together. B is 10 degrees east of north, so that would be at 80 degrees right there. So I'm going to first pick another color. We'll make B purple. So here's B. B is going to start at this point here, this crosshair point. And we're going to go 1.5, so it's actually quite a bit smaller. We go 1.5. Okay. So there it is. This is B, and it is 15 kilometers. So 35 kilometers and 15 kilometers. Now, if we go A plus B, that means we want to take this and add it onto there. So I'm not sure if I can drag and drop this over. Probably I can, but I don't know how to do that. So I'm just going to draw it on here. Won't take long at all. In order to add these, you have to add them tip to tail. So go to the edge of that. Hopefully it's lined up close enough. And we're going to start here. And 1.5. Ooh, it's close to 0.5. Yeah, it's close enough. And then we draw an arrowhead on that. Okay, well that's B there. Again, 15 kilometers. So we have A and we have B. And now if you add those two, if you basically walk in this direction and then walk in that direction, your resultant vector basically means how far are you from the starting location. So here's the starting location, and what would be your resulting vector. And so that will actually be, I'm not sure what angle that'll be exactly, so I'm going to have to just do some trial and error. That's close. It's also very close. That one's looking good. So we'll say it's right there. And I'm going to use a different color here. I use green. And the resultant vector is from here to here. So that is actually 4.5-ish. I'm going to say 4.5. So there we go. So we're going to just call it R for resultant vector. And we're going to say it's 4.5 centimeters, so that's 45 kilometers. There we go. So, and the other part of this, so that's the magnitude, and the direction is implicit because I've drawn a little scale here and I've shown basically the other ones. But if we wanted to know that angle, you'd take out, now this is a cool ruler, it's got an angle built into it, so it's 40 degrees. So that means from this line here, and maybe I'll draw another straight line. From the east-west line, it's 40 degrees. So let me just put in a dotted line here. This is just showing the east-west line. Okay. Oops. Okay. So from that line, it is triangle. Let me try that again. So that, not a vector, just showing the angle, is 40 degrees. Okay. So that, now it's really easy to tell that that's 40 degrees from the east-west line here. And so the resultant vector is that. Okay, so that's how you add vectors together. Just a little mention here. You'll notice that there's C and then there's D. So C is 20 degrees. I'm not going to draw this perfectly just because of time, but I'll just draw close to what it would look like. Let's pick another color. Let's go orange here. So for C, it says 20 kilometers at 43 degrees south of east. So you're going east and then you go south of east. So it's going to be, C is going to look like something like this. Okay, that's 20 kilometers, and it is of east, it's 43 degrees. So if this is the dotted line here, oh my goodness. I need to erase a lot of this garbage. So if this was the line, and here's the angle, this would be 43 degrees, and this would be 20 kilometers. Okay, so that's C. And then D, pick another color. Let's go black for this one. For D, it's south of west. So here's west, and we're going south. And it's 28 degrees south. It'd be something like this. It's a longer one, something like that. And here's the dotted line. Here's your angle. This is 28 degrees. And this is 40 kilometers. And this is D. Okay, so you can see these are the 4 vectors that you have to deal with on this page. And you're just being asked to add them. Now, if you say subtract D, this is D, so minus D would be in the opposite direction. So this would be minus D. okay, minus d. So when you go c minus d, that's the same as c plus a negative d. So hopefully you'll just take this vector and add it onto here, like that. Extend it out there and then find the resulting vector. Okay? Hope that helps. Let me know. Send me an email, or you can go to our Google Classroom and let me know if you need me to do any other questions.